Hello everybody. So in this example we're going to be looking at creating a basic network diagram using the precedence diagramming method or the PDM method. So first of all we're going to be given a table like this we see here on screen. So here we have the first column is activity, so activity A, B, C, D, E and F. Now obviously in real life project this activity could have actually a proper identification. So it could be for a construction project, it could be like excavate foundations, pour concrete, tying steel, etc., etc. So obviously, but just for this example, we're just going to use shorthand A, B, C, and D just to kind of save space. Obviously, if you've used Microsoft Project or Gantt charts, for example, you would have seen these kind of activities in a bit more detail. I think in Microsoft Project they're called tasks. But again, just for this example, just to kind of save space, we're just going to call it activity A, B, C, and D, and so on. The second column is the predecessor column. So what this means is that the activities in the predecessor column, they're the predecessors, the activity, and it's in the same row in the activity column. So if you see here, we have B, in activity B, the predecessor is A. That just means that A has to happen before B can happen. And then in the third column, we have duration. So again, duration could be any unit, it could be days, weeks, months. And for this example, we're just going to call it days. So activity A has a duration of 4 days, activity B has 3 days, activity C has 4 days, and so on. So this is our information we've been given for the question. So the first thing we want to do when we start off with these questions is actually just to kind of draw a rough diagram, a rough network diagram, kind of just so we can get the layout of it. So first of all, let me just pick a pen color here. Okay. So obviously we're going to start off with activity A. So we have A here, and there's no predecessor here because it's the first one, so we don't have to worry about that. So next one, if you go down to activity B, it has a predecessor of A, so we're just going to bring it up here, this little arrow, and then we have B. Then we have activity C is the next one, that also has a predecessor of A. So if we actually put it here, for example, that would actually be incorrect because C, you see in the table, has a predecessor of A, but if we put in a diagram like this, it actually has this means that the B became before it. So I'll just rub that out and we'll put it properly. So if C is also have a predecessor of A, we'll just kind of bring it down here in its own separate little area, and we'll have C here. Okay, the next activity is activity D, and this one has a predecessor of B, so that's straightforward enough. We can see kind of going across from B here, and that's going to be D. E has a predecessor of C, so you can see this again starting to make a little bit of sense hopefully to you. And we'll put E here, and then the last activity is activity F, and that has a predecessor of both D and E. So looking from the rough diagram, you can see that D and E are up the top, so obviously they're going to come together. It's the only way really that F can actually have a predecessor of both D and E. So that's our rough diagram. So now once you have the rough diagram in place, then we can actually start putting together into a bit more detail. So when you're using a PDM or a precedence diagramming method in these network diagrams, instead of actually using just a letter activity as an ID like we have in the rough one, we're going to use these things called nodes. So nodes are little rectangles with squares, and each square is divided up in different sections. So we'll just draw a quick one here just to show you what it is. And I'm going to be doing this freehand, so I say if you're going to be doing this maybe just for any exercises or assignments, it's also good just to use a ruler, but I'll just go freehand and hopefully I don't make too much of a mess. So this is our node. So it's a box divided up into a few different layers. So I'll just bring up a different color pen so we can write this out. So for this one, we actually have in this box here, I'll just make that a little bit smaller. The activity ID goes in here. And then down the bottom is the duration. So this, based on the example we're working on here, you can see we have the activity and we have the duration. So we'll use this as our basis. We'll go back to the other boxes later on, but we'll just work on getting the basic diagram set up. So we have the basic rough diagram up the top here. So now we're going to actually replace all the activity ID where we have just letters using a node. So I'll just draw the diagram with the nodes first of all. Again, I'm doing this freehand, so hopefully it's going to be nice and tidy. So this is going to be A, and obviously A then goes up to B. Let's divide it all up. I'll fill in the details in a second. And then we have B going to D. And then this goes down to F at the end. So let's fill in the node. And then we'll fill in the details. Now to do the bottom half. Again, this is why it's always good to do the rough diagram first of all, so you can see what way to lay it out. And then that was C. And this is going to be E, obviously. And then this is going to be going up to F. And I'll just put in the arrows so you kind of know which way we're going. Again, not the prettiest, but it'll do the job. So now we'll keep it color coded. So activity and duration go into two center boxes. So for the first one, the activity ID goes here, and the duration is down here. So it goes duration. This one is 4 days. So then we go up to B. So the B, the activity is obviously here, and the duration is 3 days. We'll do C again just to kind of keep the logic. So C goes here, and the activity duration is 4. So activity D, the tag goes there, and the duration here is 5. And for E, we have stick in the ID there. We have 2, and then finally we put in the activity F and the duration of 4. So that's how we basically set up a rough, no, not a rough, actually in this case, this is how we set up a PDM network diagram. So we have just the nodes, and we have the activity, and we have the duration in each of them. So this is, a nice simple way to actually do it. So what we're going to do next, though, we're going to start filling in the other boxes. So let's get another color pen here. I'll just pick a darker color for green. Actually, maybe I'll use a red. Or whatever, that'll do. Okay, so for the other boxes, we'll start off with the one up here. So this one here, the top left box is going to be called early start. Oh, that's let's make that a little bit thinner. Okay, so we have early start. Hopefully you can, this goes in this box here. And then last one, sorry, not the last one, this box here is early finish. And then the one down the bottom here is going to be late finish, and this one here is going to be late start. So using the information that we have in the table, so the activity, predecessor, and duration, we can actually then use the PDM network diagram to calculate the early start times, the early finish time, the earliest start time for the project, the earliest finished time for the project, the latest start time for the project, and the latest finish time for the project. So we'll show you now how to do this one, but that's basically how the node works. So we'll start filling them in. So we'll start off in activity A. So we start off with the early start. We always start off early start, early finish. So this is actually going to be called doing a forward pass. So I'll just get my highlighter here. So we're actually going to be doing a forward pass. This is basically where we're going to be going. We're going to start off in A and then work our way all the way through the different nodes and ending up in F. So going from start to the project to the finish of the project, that's called a forward pass. That's going to give us our early start times and our early finish times. Once we've done that, then we're going to actually work backwards doing the opposite thing again, and that'll actually give us our late finish times and our late start times. So follow along and you'll see how this works. So first thing we're going to do, we're going to put in the early start time for activity A. So obviously it's going to start on day 0 because it's the very first activity. And then we know the duration for activity A is 4. So in order to calculate the earliest finish time, it's going to be the early start time plus the duration, so 0 plus 4, and that goes into the early finish box, which is going to be here. So that's our 4. Now we'll do the same thing for node B up here. So for this one, what we do, we actually bring the 4, so the early finish time for the node beforehand is actually going to be the early start time for the subsequent node. So for B, the early start time is going to be 4, so this is the 4 from activity A, from node A. And then to work out the early finish time, same thing as previously. So it's going to be 4 plus 3 is going to be 7. And then for D, we're going to carry over that 7. So that 7 is the early finish time for the earliest finish time for B. That's now going to be the earliest start time for node D. So we'll bring over the 7. And then to calculate the early finish time, again, same thing again. 7 plus 5 is going to be 12. And before we go to activity F, you kind of see that actually it's going to be influenced by, we have C and E to do, because we have basically two nodes coming in. We have a node from D and a node for E, for activity E. They're both going to go into activity F. So before we can actually figure out what the start time and finish times for F is, we need to actually work out what C and E are, because they are predecessors of F. So D and E are both predecessors of F, and to work out E, we need to work out C. So we'll just go back and do C now. So again, for C, we're going to bring down to 4, which is the early finish time for activity A. So bring down to 4 here. And again, to work out the early finish time, it's going to be 4 plus 4 equals 8. So then we carry over the 8 from the early finish time is now the early start time for activity E. And then we have 8 plus 2 is going to be 10. So now we actually have two choices. Well, we don't really have two choices, but we'll explain it now. We have 12 and 10 here. So we're going to, which one of these do you think we have to carry over? So if you think about this logically, this is going to be the earliest start time. So if activity E is going to be finished on day 10, and we put day 10 and we say activity F is going to start on day 10, we're going to have a problem, because activity D, the earliest that can actually finishes on day 12. So you bringing up to 10 from activity E won't work, because D won't be finished. And as we saw from the table, one of F's predecessors is D, so both of these have to be finished before we can actually carry over to activity F. So in this case, when we're carrying over a number like this, we always pick the highest number. So when we're looking for the early start time of a node, and there's two nodes going into it, always pick the node with the largest early finish time. So in this case, it's going to be activity D, which is 12. So we're going to put 12 in here. And again, we'll work off the early finish time. So it's going to be 12 plus 4 equals 16. So now we can actually see that 16 is now actually our project duration. So this is actually what we did there is our forward pass. So that's kind of working out using the network diagramming method, what the project duration is. And that's again, just by using the early start times, the duration, and the early finish times, we can work through them all. And then we've ended up with 16 at the end. So that's our project's length. So what we're going to do next now is going to be our backward pass. We have to start filling in the latest start times and the late finish times. What this means is that's just the latest an activity can start and the latest an activity can finish. So again, just to maybe clear things up, I will pick a different color so we can see a bit better. So late finish time. So this is going to be called the backward pass. So we've done the forward pass going from A all the way through to F. So now we're going to do a backward pass. Fill out the bottom half of the node, the bottom two left and right corners of the nodes, and just work our way back from F all the way back to A. So it's the same thing, but it's doing the opposite of what we did previously. So let's see that now. Okay, so to get this going, we need to bring down this 16. So the 16 is the earliest finish time for the project. So to actually do the backward pass, we actually just bring this 16 down to here. So it's actually going to be 16 in here as well. Again, the green is going to represent the backward pass. Now, again, we're going to just do the exact opposite of what we did. So on the forward pass, what we did, we used to add the early start time and the duration together, and that gave us our early finish time. In this case, we're actually going to just subtract the late finish time and the duration from the late finish time. So it's going to be 16 minus 4. That's going to give us 12. And again, we can just work away. We'll just do D and B first of all. So, and we're going to carry over the 12 from activity F. So that's going to be the 12 is the latest start time activity F can start at. So we'll bring that 12 up to activity D. And then 12 minus 5 is going to be 7. And that's fine. We're going to carry over that 7 onto activity B. So again, the latest start time for activity D is 7, and that is also then going to be the latest finish time for activity B. And then we'll continue on. 7 minus 3 is going to be 4. And obviously, like last time we were filling out F on the forward pass, we can't fill out A just yet because we have to actually do E and C first of all. So we'll just go back and do that. So again, from F we worked out that the late start time was 12. So we'll just bring that 12 down here. And then 12 minus 2 is going to be 10. So the latest start time for activity E is 10. So we'll carry over that 10 onto activity C. So that 10 now is going to be the late finish time for activity C. And then 10 minus 4 is going to be 6. And again, like we did last time when we were doing the forward pass, we had two nodes going into activity F. So we had D and E both going into F. And in that case, we just picked the time, the largest duration, the largest number for the early finish time. So in the previous one, it was like D had a 12 and E had a 10, so we picked a 12. Because now we're doing the backward pass, we actually do the opposite. So in this one, the latest start time we have to carry over for activity C is 6, and the latest start time for activity B is 4. So instead of actually going with the biggest one this time, we actually go with the smallest one. So we carry over the 4 like this. And again, we'll just finish off the node. 4 minus 4 equals 0. So that's basically how we actually fill out the nodes, doing our forward pass and our backward pass. Now we can actually use this information to identify our critical path. There's a few different ways we can do the critical path. And we'll do the slightly more detailed one in another video, but for this one, we'll just show you quickly how it's done. So I'll just select highlighter here so we can see everything a bit better. So in order to identify the critical path, again, we'll show in a different way later on using floats and stacks and all this type of thing. But for this example here, probably the easiest way to do it is actually if you look at the early finish times and late finish times, if they're both the same, that's going to be a task that's going to be on the critical path. So the critical path means that's your path, that's your list of activities that if there is a delay in any one of those activities, there's going to be an overall delay added to the end of the project. So we'll show you now in a second what that means. So I'll just highlight this here. So we have activity A. So we have 4 and 4 there. So the early finish and the late finish are about 4 and 4. So that's it. So we look at activity B and C. So in B, we actually have the early finish is 7 and the late finish here in green is 7. And then C, the early finish is 8 and the late finish is 10. Obviously they're both different. So activity B is then going to be the one we're looking for. Okay. And again, you can probably just from logic point of view that it's going to be probably more likely, or it is going to be D. So we see the early finish time and the late finish time are about 12 for activity D. So we'll do that. And then obviously that's going to go down and finish on activity F. So you can see now, just highlighted here in yellow, that this is our critical path. So I'll just fill it in. And we'll just make it stand out a different color again, just for the, what we give it? We give it a purple, or whatever this is. So critical path equals A to B to D to F. So now we've identified the critical path. What we now know is that if there's any delay to any one of these activities, there's going to be delay in the overall project. So we knew the whole project is going to last 16 days. So say for example, if activity B was delayed by 1 day, what would happen then is that'll actually delay the whole project by 1 day. But if you look at activity C and E, they're not part of the critical path. What that means, if there's actually a delay in those activities, it won't necessarily cause a delay in the overall project. Again, this can be seen in the early finish time, the late finish time. So you can see there's actually an 8 and a 10 here for activity C. So the early finish is 8 and the late finish is 10. That means the earliest activity C can finish is on day 8, but the latest it can finish is day 10. So technically, activity C could be delayed by 1 day, and that still wouldn't actually have an overall effect on the overall duration of the project. So again, using the critical path, it just helps identify the main activities you need to keep an eye on a project. So hopefully this made a little bit of sense. And we'll do another example in the next video. So follow along with that one. Again, I encourage you, instead of just watching this video, just kind of write down these notes and work through it with me. You'll just learn a lot quicker. But just to summarize our actual points here, so I'll just bring up a pen. So for, I guess, a step-by-step guide to doing this example here. So step 1 is going to be draw a rough diagram. First of all, just to kind of get your overall outline. Step 2 is going to be, Step 2 is going to be draw the PDM network with nodes, which are the boxes here with the activity, duration, etc. Step 3 is perform the forward pass. Again, that's just taking using the early start time, the duration, to work out the early finish time. And then step 4 is to perform the backward pass. And again, it's just the opposite. It's basically just using the late finish time, the duration, to work out the late start time. And then I suppose for this example, the last one we did was to identify the critical path. So that was the main part of this one. So if you've done this much for this example here, you'll have the guts of your question done. For the next video, we'll show how to do a little bit more. That's usually a bit more for identifying the critical path. There's things called float and stack and all this type of thing. So we'll look at that in the next video. So, but have a look at this one first of all. Get your head around this. Get your logic into your head, and then hopefully then the next videos will make a bit more sense when you go into a bit more detail. So, okay, thank you, and I'll see you in the next video.